So far, we covered the essentials in our AlgoKit journey: project initialization, smart contract creation, and comprehensive testing using both AlgoKit utils and DAFlow. But how do we integrate the smart contract we've written into a web frontend, enabling users to interact with it? Hello everyone, my name is Chris Kim, and in today's video, we're going to learn how to easily deploy and interact with your smart contract using the auto-generated AlgoKit application client created with the AlgoKit Generate feature. When you're building a web application that needs to communicate with a database or an API endpoint, you have to write code that makes that API call to that endpoint. Now, building a decentralized application is not all that different. You need to write code that calls the smart contract you've created, much like making API calls to an endpoint. Now here's where AlgoKit's auto-generated application client comes in. Before AlgoKit, developers had to manually define functions to connect to the Algorand node, locate the deployed smart contract, construct transactions, and send them to the Algorand network using the raw Algorand SDK. Now just imagine having to go through that process for every interaction with the smart contract. Now with AlgoKit, you can auto-generate an application client that acts as your gateway to your smart contract with a simple one-liner command: AlgoKit Generate Client. In this video, we'll explore the auto-generated application client by walking through the process using an existing AlgoKit project. Not everyone wants to start from scratch, and oftentimes, using and modifying existing code is a much more efficient approach. To help with your learning, I've created a Github repository containing a simple calculator AlgoKit project. You can clone this repository and follow along with the video. It'll be like a mini workshop experience. Alright, first head over to the learn-algokit-ts-client Github repo. The link is in the description. Now let's clone this repo by coming over here, copying this, going to your terminal, and type in git clone and paste in that link you got from the repo. And there you go. The repo is cloned into my local machine. So if I look in this folder, now I have learn-algokit-ts-client folder created inside of it. So let's cd into that. And let's open this up in a code editor. I'm using the VS Code editor, so I'm just going to do code dot to open the file. Now this project was created by using AlgoKit's beaker template. So everything you see over here is what you can expect from a beaker template. All these files are configurations for the beaker template, so you don't really have to worry about them. And all you need to worry about is this smart contracts folder over here. Now if you open that up, there's a folder called calculator, and inside of it there's a contract.py file which includes the beaker and pyteal smart contract with 4 of the calculator methods defined in there. The deploy-config.ts file over here is where you define your deployment and contract interaction logic, and you can use this to test the functionality of your smart contract. So as you can see over here, we're instantiating the AlgoD client, the indexer, creating an account called deployer, ensuring that the account is funded, creating a new app client for the calculator app, using the app client to deploy it, and then funding the smart contract, and then calling the 4 calculator methods down here. So all of the deployment and smart contract interaction logic is predefined over here, so you don't have to worry about this, because this video is more about AlgoKit's generate feature that will auto-generate the calculator application client, which we import over here and use it down here. Now to give you a little bit more explanation on how to instantiate the application client using the auto-generated application client, you instantiate it by doing new calculator client, where calculator client is imported over here. Now for the first argument, you pass in the app details parameter. And here inside the app details parameter, we're saying that resolve by is set to creator and name. So what this means is, if you've previously instantiated the same application client and deployed the same smart contract, it will detect those existing apps with the creator's address and the name of the contract. And it will find the existing apps using the indexer. This is saying that every transaction that is sent with the application client will be sent and signed by the deployer address. And here we're specifying that the creator's address is deployer wallet.addr, so the address of the deployer account. If you want to learn more about the app details parameter and what you can do with it, head to the AlgoKit utils-ts app client documentation. The link is in the description. And then as a second parameter, you pass in the AlgoD client. You instantiate over here in line 8. Now coming down here, when we look at app-client.deploy, we're also setting some settings inside of here. Here we can see that both onSchemaBreak and onUpdate is set to append. So what this means is whenever you change the smart contract so that the schema requirements changes, or you update the smart contract, this app-client.deploy will leave the existing app and create a new one and work with that newly deployed smart contract. If you want to learn more about what you can set during deployment, head to the AlgoKit app deploy documentation. The link is also in the description. Right now, we didn't build the smart contract and the application client, so that's why we're seeing the red line over here. Inside the helpers folder, there's a build.py file, which is the logic that will build the smart contract and also automatically generate the application client over here. Config.py file contains logic that will automatically detect all of the smart contracts you have defined inside of the smart contracts folder. And index.ts file contains the code that actually deploys and interacts with the smart contract by running the deploy-config.ts file. What's great about the Beaker template is that all these files exist so that when you come to run and debug in your VS Code editor, you can run these 3 debug scripts to seamlessly launch a local network that you can test on, to deploy your smart contract, and to call your smart contract. Now, before we go ahead and run these debug scripts, we need to set up the development environment for this project. Because we cloned this AlgoKit project from a Github repo, the development environment on your local machine is not set up yet. So to do that, open up your terminal and then run AlgoKit bootstrap all. And this command will automatically install all of the dependencies that you need to build your smart contract and to deploy and test your smart contract. All right, once your bootstrap is finished, let's go back to run and debug and try running the build and deploy Beaker application script. Now you can just click this green arrow over here, or you can click F5 to run the debug script. So let's see what happens if I run this. Before you continue, make sure you have your Docker desktop running in the background. First, it's going to start AlgoKit's localnet automatically, and then it's going to run the deploy-config.ts file. And if I expand this over here, you can see starting from deploying calculator, you see that it detects that localnet account deployer doesn't exist yet. So it's creating that account over here and funding it with 3 algos. And then it's deploying the calculator app over here. And then down here, we're calling the 4 methods: the add, the subtract, multiply, and divide. And all of them return the value 15. All right, let's go back and see what actually happened. So if you go back to the File Explorer, you can see that the artifacts folder is now created. This is because it ran the build.py file, which automatically created the artifacts folder and then created all these artifacts and the application client. So if I open up the artifacts folder, we see the application.json file, which is the extended API, approval program, the clear program, and the client.ts file over here. So this is the auto-generated application client that you use in your deploy-config.ts file. The client.ts file is quite complicated, but don't worry, you don't have to understand any of this code to use it. Now, if you go back to deploy-config.ts file, let's see how you actually use the auto-generated client. Now over here, we're importing in the calculator client from the client.ts file. And here we're instantiating a new calculator client like this. So this is how you instantiate an application client that you use to deploy and call the methods inside of the smart contract. To deploy the application, all you need to do is do await app-client.deploy and define some settings inside of it to deploy the smart contract. Now coming down here, to call the smart contract method, for example, the add method over here, you do await app-client.add, and then you pass in the arguments inside of the bracket. So if you quickly go back to our smart contract, the add method takes in 2 arguments, A and B, and it outputs a UN64 type. So inside of the bracket, I'm passing in 10 for argument A and 5 for argument B. which is why it returned a 15. Now you can also generate the application client through a CLI command. So let's delete this file for now. And then open up your terminal. And to create the application client, type in AlgoKit generate client. And then you want to pass in the relative path to the application.json file, which is inside of the artifacts folder over here. So that would be artifacts/calculator/application.json. Next, you want to pass in the path where you want to output the client.ts file. So to do that, you need to do -o and then pass in the relative path. Now, since I want it in the artifacts/calculator folder, I would do artifacts/calculator/client.ts. So you can name it differently. So I could do calculator client.ts and that would work as well. Now, if I run that, it's going to automatically generate the TypeScript client and output the file inside of the path that I passed in, which is inside of the artifacts/calculator folder. And there you go. It's the same application client that we had before. And if you run the debug script again, you'll see that it runs perfectly fine. There you go. It successfully ran the deploy script inside of deploy-config.ts file. Now, if you go back to the deploy-config.ts file, this is what your front-end code would look like. In your front-end, let's say you're using React framework. Inside of your React project, you would instantiate the AlgoKit clients and the indexer. And for your production application, you won't be using local net. So you would use external Algorand wallets and integrate it into your React project. You instantiate the application client using the auto-generated client over here, and you would interact with your smart contract by calling the methods like this. So as you can see, this auto-generated application client makes your smart contract deployment and interaction super simple and super easy to do. Today, we learned how to generate an application client using the AlgoKit generate client command and how you can use the client to deploy and interact with the smart contract. The auto-generated application client is extremely powerful as it provides a simple interface you can interact with to deploy and call your smart contract. The app client greatly improves the developer experience in Algorand, and it will drastically simplify your code base to build a full-stack Algorand application. Now, if you have any questions, head to the Algorand Discord channel to get your questions answered by the developer relations team or the Algorand developer community. Also, if you like this video, make sure to give us a like and subscribe to stay in the loop. That being said, thank you so much for watching. I'll see you in the next one.